Hi, in this lesson I want to take you to the far northwest of Scotland, to a place called Laxford. This is an amazing place to go and visit. It's somewhere I really enjoy spending time, partly because the landscape is astonishing, but also the geology is gobsmacking. And what I want us to do today is I want us to explore a little part of the geology of this area, to show you how geologists could go about relative dating of rocks that we find in outcrops. Now, for this lesson, we're going to be looking at three specimens: specimen H, specimen K, specimen Z. There'll be a description of those coming up shortly. And you will need a Laxford data sheet. It has this on the title and a photograph of a rock exposure. Okay then, let's go to Laxford. If you go about a mile north or so of the Laxford Bridge, you come across a spectacular road cutting. This is the cutting we're going to be trying to pick apart its geological history. We need to think a little bit about what we would actually do if we're trying to work out the geology of a site like this. Now, as geologists, perhaps our first instinct is to go and try and identify the rock types that we find. Because we'll find there are three different rocks exposed in this outcrop in the side of the road. Fortunately, because it's a road cutting, this is really nice and clean because it's quite fresh. The almost vertical lines you see running down through the outcrop, those are actually holes that were drilled in the rock to be able to blast it out to make this road cutting. As you'll see, this is quite hard, quite resistant rock. Okay, so let's have a look at the rock types. These are specimens H, K and Z. Let me show you what those are actually like. These are the three rocks from the Laxford area. If we look at them alphabetically, in order of their labels, this is specimen H. Specimen H, you can see, is completely crystalline. But specimen H has some very distinctive bands of different coloured minerals within the rock. We can see lighter coloured bands that have a grey vitreous mineral, a white vitreous mineral, and a pink vitreous mineral. The darker coloured bands have a greenish black vitreous mineral, and possibly even a dark coloured flaky mineral. But we can see there are distinctive bands within this rock. Specimen K is also crystalline. Now, specimen K has some very distinctive crystals within it. It has a lot of very light coloured vitreous minerals. You can see the grey or colourless one there. There's a large quantity of the pink vitreous mineral and some white vitreous mineral as well. Very distinctively, there are crystals here of a silvery mineral that's grown in these flat, very reflective, sort of flaky crystals. if we look at the size of these crystals, they are well over a centimetre across. This rock is extremely coarse-grained. The final rock we find at Laxford is also crystalline. It's much darker in colour. We can see a white vitreous mineral in it, a greenish black vitreous mineral, making up the bulk of the rock. But there's also a small quantity of green vitreous mineral as well, giving it a very distinctive appearance. The crystals in this rock are maybe somewhere between 1 and 2 millimetres across. Those are examples of the 3 rocks that are found in the rock cutting at Laxford. Can you identify what rocks they are? Okay, so we've seen these 3 rock types. This is a photograph of rock H. The scale on this photograph is a pound coin, so you get some idea of how big this is. You can see, as we've just had the description of the specimen, the clear banding of minerals within this rock. And this is rock Z, the darker colour rock. Again, we've got a pound coin for scale, so we can see distinct crystals here, maybe between 1 and 2 millimetres across. And then we see the much coarser and also much lighter rock K as a band running through rock Z there. Okay, you need to, before we go any further, make sure you've got some good descriptions of those rocks, and then we've got a good understanding of what type of rocks we're actually looking at there. Can we name them, for example? Do we know whether they're igneous, sedimentary or metamorphic? Make sure you've got a description on your data sheet. Okay. So now as a geologist, we're looking again at this outcrop. We've worked out what type of rocks we're dealing with here. So we can start to think about the type of dating strategies we're going to use. And we need to think about how we're actually going to investigate the geological history of this site. How can we establish the age relationships between these rocks? Now, clearly, to be able to do this, we need to look at where these rocks actually come together. We know what type of rocks we're dealing with. Where's the boundary between them? How do they relate to each other? So to be able to do this, we need to think about where we can find the evidence. And we're going to look at sort of 3 places initially. The photographs that go with these are available as a PDF. Okay, let's go and have a look at these sites then. This is location 1 on our site. So here we've got a pencil for scale, and here we can see rock H and rock Z next to each other. We need to think about what the boundary between these two might be. Remember, the key feature of rock H are these bands of minerals. Now we can see these bands down here near the bottom of the outcrop shown in this photo, roughly parallel to this very clear boundary between the lighter coloured rock H and the darker coloured rock Z. What could these be? What's it showing us? Let's go back to the outcrop picture. So this was the area around location 1. Let's have a look at this boundary here with location 2. Here we can see we've got rock H here, and it's distinctively very large crystals. Again, we've got a pound coin for scale, so we can see just how big some of these crystals are. And surrounding that, we've got rock H. And there's quite a sharp boundary, see, running down through here, if you follow the cursor, between the two rocks. And another very similar boundary between the rocks running up here. We can also see the banding within these rocks. You see, running here roughly horizontally. Over here it's a bit more vertical, but we can certainly see some clear banding. So what's the relationship between these rocks? Which of these rocks, for example, is older? Which is younger? How do you know that that's the case? Okay. We also have then location 3, which covers this area down in the bottom left. Here we can see rock K and its very coarse crystals, and rock Z, the darker coloured crystalline rock. You can see that it's not a nice straight line between the two, although the boundary does seem to be quite sharp. So what do you think the age relationship is here? What's going on? What sort of structures do these rocks form? It's really interesting to see these little sort of almost injections of rock H, perhaps exploiting weaknesses here, perhaps along here in rock Z. Ignore these vertical lines here. Those are drill holes for the blasting. What's the relationship between these rocks? Okay, so at locations 1, 2 and 3, we've now seen 2 of these rocks close to one another. If we want to try and piece together the whole picture though, we need to have a look down here at the bottom. Let's look at an area that perhaps will give us a bit more of a summary of these. Here we can see all 3 rock types together. Again, we've got a pound coin for scale, but we can see the banding clearly in rock H there. You can see the sharp boundary between H and rock Z. There's also a very sharp boundary between rock Z and rock K. And if you notice, just down the bottom right hand corner there, we can see rock K and rock H coming into contact. So can we work out the relative age of these rocks. Bear in mind the principles that we've been learning, and also what type of rocks are we actually looking at here. See what you can work out. Annotate your photograph to explain, or should I say describe the evidence first, and then can we draw some conclusions? What is the history of this area? See what you can work out. So, as we watch a West Highland sunset, we now have enough information to come up with an interpretation of the rocks in this area. What type of rocks are we looking at? What are the processes that form those rocks? And crucially, what sequence did they occur in? What's their relative age? Okay. Have a go at that now. Complete as much on your Laxford datasheet as possible. And let's see what we can work out about the geology.